Hi, we are now in the second subtopic of chapter 3, which is binomial expansion. But before that, we introduce you n factorial. So for any positive integer n, we define n factorial as n times n minus 1 times up to times 1. So it means here, we have to start with n according to our factorial and ends with 1. So look at n plus 1 factorial. As previously, we have to start with n plus 1 and then multiply by the term minus 1 from the previous term, which is n, times n minus 1 up till 1. We can also write this in the form of n plus 1 times n factorial. Next is the binomial coefficient. We can write it in the form of this one, which also means NCR equals to n factorial divided by n minus r factorial times r factorial. So now we will look at the binomial expansion. For any positive integer n, we have the following expansion. With a and b given, we start with nc0 a to power n times b to power 0, and doing so up till ncn times a to power 0 times b to power n. Now, look at example 19. We have to evaluate 5 factorial here. So, as stated previously, we have to start with 5 itself and then times the term minus 1 from the previous term up till 1 as follows to get 120. For D, we have 5C2 with n equals to 5 and r equals to 2. Substituting this n and r into the formula of the binomial coefficient, we have the following, and simplify it, we will get 10. And we are done. Now, example 20, we have to expand the following by using binomial expansion. We can see here that our n is a positive integer. So we have n equals to 4 with a equals to 1 and our b equals to minus 2x. We then need to substitute all these three numbers into our binomial expansion formula to get the following. And then we have to carefully calculate each term as follows. Carefully calculate it means, so for example, I take the third term here. We have 4c2 equals to 6, 1 squared equals to 1, and then for the term in the bracket, you have to expand minus 2 to power 2, which is 4, and then x to power 2, which is x squared. Now calculating each coefficient carefully again, we'll get 1 minus 8x plus 24x squared minus 32x cubed plus 16x to power 4. Next, example 21. We first have to expand the following expression in ascending power of x and hence to find 1.02 to power 5 up to 4 significant figures. Now, we have n equals to 5 with a equals to 2x and b equals to 1. Similarly, as in previous example, we have to substitute our n, a, and b into our expansion formula to get the following expansion. Then, carefully calculate each term to get the following expansion. But note that the question asks for ascending power of x, so we need to rearrange the answer in ascending order of expansion. Now, we have to find 1.02 to power 5 from our binomial expansion. To do so, we have first to separate 1.02 into two terms as follows. 1 plus 2 times 0.01. We do this in order to compare with our previous binomial expansion as this one. And note that our x here is 0.01. With this x, we then substitute into our binomial expansion that we found earlier to get the following. And then calculating it, we will get 1.02 to the power 5 equals to 1.104, correct to 4 significant figures. And we're done. Hi, we are now still in chapter 3. Now we have a formula to find the r plus 1th term of our binomial expansion, a plus b to the power n, and it's given by tr plus 1 equals to ncr times a to the power n minus r times b to the power r. So we shall look at example 22. We have to find the 5th term, which is t5 in our expansion given, with n equals to 6, a equals to 2, and b equals to minus x. So substituting our a and b into tr plus 1, we then get ncr times 2 to the power 6 minus r times minus x to the power r. We are to find t5, so we have to compare r plus 1 with 5, which means our r is 4. Then substituting this r equals to 4 into our tr plus 1, and then simplify the coefficients, we will then get t5 equals to 60x to the power 4. And we're done. For example 23, we have to find the term independent of x in the following expansion, with a equals to x and b equals to 1 over x. Similarly, we have to substitute our a and b into our tr plus 1 formula. And here, we have to simplify our 1 over x into x to the power minus 1 in order to simplify the x, where we can put together x by adding the powers. And then we will get tr plus 1 equals to 8cr times x to the power 8 minus 2r. The term independent of x means we have x to the power 0. And to do so, we equate 8 minus 2r here, the power 8 minus 2r, we equate it to 0. And then we will get our r as 4. Now, substituting our r equals to 4 into our tr plus 1 formula and simplifying it, we will get t5 equals to 70, which means the term independent of x is 70, which is the 5th term. And we're done. In example 24, we are to find the coefficients of x to the power 5 in the expression given, with a is 1 and b is 5x. So substituting a and b into the tr plus 1 formula, but here we have to separate the ones in the bracket as follows. So 8cr times 1 to the power 8 minus r times 5 to the power r times x to the power r, in order to get the coefficient of x to the power r. So for coefficient of x to the power 5, we then have r equals to 5. So with this r equals to 5, we substitute it into our tr plus 1 formula and then calculate the coefficient carefully. We then get T6 equals to 175,000 x to the power 5. So the coefficient of x to the power 5 is 17175,000. And we're done. Hi. Now we are still in the second subtopic for chapter 3, which is binomial expansion. This time, we have the binomial expansion formula for 1 plus x to the power n, where n is a fraction, for any negative integer, which is 1 plus ax to the power n equals to 1 plus n ax plus n times n minus 1 over 2 factorial times ax squared plus n times n minus 1 times n minus 2 over 3 factorial times ax to the power 3. Note that to use this expansion formula, we have to have 1 inside of the bracket and n is a fraction or a negative integer. And for this expansion, it is valid for the modulus of ax less than 1. Then we can write in the form of x between minus 1 over a and 1 over a. Hence, if we have a plus b to the power n, since there is no number 1 in our expression here, we then have to factor a out to get a times 1 plus b over a altogether to power n. Next, we expand each term to power n to get a to power n times 1 plus b over a to power n. Now, we notice that this one we have 1 in the bracket. So we can use the previous binomial expansion to expand this expression. So with a to power n still outside of the bracket to be multiplied by the one we expand using the previous binomial expansion, we can get the expansion for a plus b to power n, which is valid for the modulus b over a less than 1. So b over a here is the same as the one we factorized previously. So now look at example 25. We have to expand the following in ascending powers of x up to the term x to power 3, and hence to state the validity interval for the expansion. We look at b. We have to expand 1 minus 3x to the power 1 over 5. So we have here n, which is definitely a fraction of 1 over 5, and we have a equals to minus 3. We can see here that we have 1 in our bracket, so we can simply use our binomial expansion formula earlier and substituting n and a as we found as follows. And carefully calculate the coefficient of each term. We then have 1 minus 3 over 5x minus 18 over 25x squared minus 162 over 125 x cubed plus so on. And don't forget, the expansion is valid for the modulus of minus 3x less than 1, which is x between minus 1 over 3 and 1 over 3. And we're done. Next is C. We have to expand 16 plus x to power 1 over 4. Note here, we definitely have n in fraction, but we don't have 1 inside the bracket. So to do so, we have to factor 16 out of the bracket to have 16 times 1 plus x over 16 to the power 1 over 4. and then expand each term to power 1 over 4 to get the following. Next, we simplify 16 to the power 1 over 4 to get 2, and then simply expand 1 plus x over 16 to the power 1 over 4 using the previous binomial expansion formula to get this expansion here. And multiplying the expansion by 2, we then get 2 plus x over 32 minus 3 over 4096 x squared plus 7 over 262144 x cubed plus so on. And the expansion is valid for the modulus x over 16 less than 1, which is x between minus 16 and 16. And we're done. Next, we have example 26. We have to expand 1 plus 3x to the 1 over 3 in ascending powers of x until and including the term x cubed. And by substituting x equals to 1 over 125, we have to determine the value of the cube root of 2 correct to 4 decimal places. So first we have to expand 1 plus 3x to the power 1 over 3 with n equals to 1 over 3 and a equals to 3. And since we have already 1 here in the bracket, so we can simply substitute our n and a into the binomial expansion formula as follows. And again, carefully calculate for the coefficient of each term. We then get 1 plus x minus x squared plus 5 over 3x cubed plus so on. Note that the left-hand side is 1 plus 3x to power 1 over 3. The question asks us to substitute x equals to 1 to 5. 1 over 1 to 5. So then we have to substitute x equals to 1 over 1 to 5 into the x for both sides of the equation, the left-hand side and on the right-hand side of the equations. Therefore, we have the following equation. So for the left-hand side, we just need to simplify the fraction inside the bracket to get 1 to 8 over 1 to 5 to the power 1 over 3, and then calculate to get the figure 1.007937 on the right-hand side. So note that again, we have to find a value for the cube root of 2, which is still nowhere to be found in this equation. So to do so, we have to write the one in the bracket here in a multiple of numbers. So we can write down 1 to 8 as a multiple of 4 to the power 3 times 2. And then the 1 to 5, 5 to the power 3. So simplify this fraction here. We then get 4 times cube root of 2 over 5. Now, we can see here the cube root of 2 that we want to find. And to get the cube root of 2, we have to multiply both sides of the equation by 5 over 4. And then we can get the cube root of 2 equals to 1.2599, correct to 4 decimal places per asked in the question. And we're done. Now we go to example 28. Determine the first 4 terms in the expansion of cube root of 1 plus x in ascending powers of x. State the range of x for which the expansion is valid, and hence evaluate the cube root of 8.08 correct to 4 significant figures. First, we have to expand the cube root of 1 plus x, which can be written in the form of 1 plus x to power 1 over 3. We can see here that the power is in fraction, so we can use the expansion formula 1 plus ax to power n as given here. And since we have our ax equals to x, or a equals to 1 with n equals to 1 over 3, and we also have 1 in our bracket here, so we can simply use our expansion formula given here. So substituting our a and n, we can then get this expansion. Carefully calculate for the coefficient of the terms of the term. We then get 1 plus 1 over 3x minus 1 over 9x squared plus 5 over 81x cubed plus so on. And the expansion is valid for modulus x less than 1, which is x between minus 1 and 1. Now, we have to evaluate the cube root of 8.08 here. And we need to evaluate this by using the binomial expansion that we did earlier. So we have our binomial expansion of 1 plus x to power 1 over 3 as follows. So in order to use our binomial expansion, we have to find a value of x to be substituted in the left-hand side and also in the right-hand side of our equation. So how to do that? How to get our x? So first, we try to compare 1 plus x equals to 8.08. But by doing so, we get x equals to 7.08, which is out of range. So now, we try to do other method, which is from the cube root of 8.08 or 8.08 to the power 1 over 3, we try to write the 8.08 here in two terms, which are 8 and 0.08. Now remember that to use our expansion formula, we have to have 1 in our bracket, which we don't have here. So to do so, we have to factor 8 out to have 8 times 1 plus 0.01 altogether to power 1 over 3. Then expand each term to power 1 over 3. We have 2 times 1 plus 0.01 to power 1 over 3. Notice that this one is similar to the one we expand earlier. So we now then have our x equals to 0.01, which is still within the validity range. So by substituting our x equals to 0.01 to the left and to the right hand side of our equation, we then have the following equation and simplify it to get the cube root of 8.08 as 2.007. And we're done. That's all for chapter 3. Thank you.